Saxon Algebra 1, Lesson 31. Greetings, my students. Today we're going to bump up our game a little bit on equations, and we're going to deal with some equations with parentheses. Remember that whenever you see parentheses, they speak to you. Did you know it? And you know what they say? They say, do me first. When it comes to order of operations, our parentheses and other shapes like that, which we very fancily call symbols of inclusion. That's the fancy math word for things like parentheses or brackets, which are squared off, or I'm not even sure what they're called when they have like the little pointy thing in the middle. They can be any style. Symbols of inclusion is the technical term that includes all the different shapes. But I think today we're just doing basic rounded parentheses. And later we'll get crazier. All right, so we always tackle those first. Let's take a look at what this looks like. 31.1. And we have, I'd just like to look, we have 5 problems to handle today. Solve is our instructions. Whenever we see solve, we know that we have an equation. And we're going to get an answer of like x equals. It might not be x, but we'll get an answer that looks something like that, okay? If we have instructions that tell us to simplify, that means we have an expression, no equal sign, okay? And that means our answer is probably not going to be so precise. All right, so John's telling us in this one to solve 31.1, and here's the way it looks. Copy, please. Okay, pretend I skipped a line here. It looks a little crowded. So here's what we've got. We've got an equation with an equal sign, and we want to get rid of that first, do me first. And so what we realize is, oh, this is a distribution scenario, isn't it? We want to use the distributive property to do this multiplication, and then we can throw the parentheses out the window. So we multiply. 2 times 3 is 6. 2 times, and then we put the minus sign, 2 times b is 2b equals b minus 5. The other side's unchanged, we just copy it. Now we're cooking, and we can just follow our usual path of steps to solve an equation. First, we look to see, can we add any like terms on the separate sides of the equation, right? Remember, when we're adding like terms, we're just combining things together. We don't see anything. Now we're ready to swim fish. I see I'm going to swim the b's this way because then I'll have positive b. I don't like that negative. So I'm going to add 2b. That cancels. I get 6 equals 3b minus 5. And so then I'll swim the plain numbers. I don't remember, have we been practicing? Soon we can do that in one step. I don't know if I've gotten there yet, but this cancels and we get 11 equals 3b, and we divide by 3. And this is what I like to do. Okay, that's gone. Now, instead of rewriting this, I'm just gonna write equals b over here. And now I have a nice, neat answer without recopying. It's so easy to make mistakes just from recopying. Please don't. Okay, yay. That's the first one. Okay, the next one, 31.2. Solve. 3 times the quantity. I won't say it out loud. Copy with me, though. Okay. I'll give you a second to catch up. We see that there are parentheses on both sides. Okay, that's fine. We can handle it, right? Again, parentheses say do me first. So the first thing we're going to do is deal with our parentheses. I'm going to make a list here of our steps. And we're going to have to distribute this one and this one. And then over here, we'll have to do the same. And we're going to need to be careful because, look, that's a -4. Minus signs aren't hard to distribute. You just have to make sure you don't forget about them because they're easy to overlook. So let's do this side first. 3 times 1 is 3, plus 3 times 2x is 6x. Now, this guy is just trailing along after this little distribution group. It's fine. This is like when you and your friends go to the store and your mom makes you take your little brother along. He's just chilling. Let him come along. There he is. Okay, over here, we just have to be careful and distribute that minus sign. So -4 times x is -4x. And then -4 times +2 makes it -8, right? Okay, so we distributed, and I'm just going to write that after here because that's how we make the parentheses go away. The second step is add like terms. And I see those guys can go together. So I'm going to write 6x plus 10 equals -4x minus 8. Remember that when we're combining like terms, we're working just on the same side of the equal sign. Nobody's swimming any fish when we add like terms, so you don't have to do anything tricky with the opposite signs or anything like that. Sometimes students think that adding like terms means you have to like swim them together. No, they're already together. We're just squishing them. Okay, now we're ready to swim fish. That's where we're sending guys back and forth across the equal sign. I see this -4x and I would like to add it. Remember that it doesn't matter. You can swim any of the matching fish in either direction as long as you're matching x's with x's and plain numbers. You can swim them in either direction. It'll all work out in the end. So I'm going to add 4x here. And then if you're ready, what I do is, okay, so that cancels. That means I'm swimming plain numbers this way, so I can subtract 10. You can do it in one step. Swim both types of fish in the same step. Just be careful that you're swimming them in opposite directions, right? The x's are coming this way, and the plain numbers are going that way. So I get 10x equals -18, and I divide both sides by 10 to isolate our x, and that's cool, and I get x equals, and then I'm going to divide this by 2 over 2 because I can see that would reduce, and I'm going to get -9 over 5. John agrees. Yay! Okay, swim, fish, and then solve is that last step, right, where we divide away. Okay, that's number 2. Ready for number 3? Let's challenge me to get it into this little space down here. Example 31.3. Here we go. 15. Sorry, I can't resist saying it out loud, but I don't need to. This one's really not any harder than that one. It's just got some bigger numbers in it. 15, just double checking to make sure I wrote it properly. Yay, that looks good. Okay, same as always, we distribute first. I always draw these because you know what, you guys? It's super easy to forget. We all remember to do the first one, but the second one, sometimes people just forget it. So I always draw what I technically call the whoop-de-doops. Do you guys know the Smith girls? Mackenzie and Isabel and Natalie Smith. They moved to Texas a year or so ago. Has it been just a year? Maybe it's been 2 years by now. Anyway, Natalie and I used to always call these whoop-de-doops. I taught math to all of them. Okay, let's do our multiplications now. 15 times 4. Okay, 15 times 2 is 30. So 15 times 4 would be 60. 5, well, that would be 75, right? No. Yes. Let's just check it. 15 times 5. Yeah, 25. 7. Okay, so I've done the multiplications there. Equals. Okay, what's 16 times 4? Remember, there is no shame in this game, you guys. I'm writing them sort of small, but I'm not trying to hide these. And oh, please don't do them on scratch paper. Don't do that. They're a part of your calculation. Be proud of them. Okay, 16 times 4 I figured out is 64. And then 16 times 6 is 36. All right, this was a positive number. There's the minus sign, so I was careful about that. These numbers are just a little bigger, but it looks a lot like that, doesn't it? Okay, so then we've distributed. Now we're gonna add like terms, and I see there's a plain number and there's a plain number on the same side. We can put them together. So 60 minus 75x equals 74 minus 96x. All right, I want to add 96 to both sides. And I'm going to cross that out so I can see, oh, okay, there's my plain number, so I'm going to bring him over here. I'm down at the bottom of my page. Let me scoot up a little. Okay, so that's gone. Negative 76, positive 90, or 75, 96, 21x equals 14. All right. That's pretty cool. And so I'm going to just copy that over here. 21x equals 14. I'll divide both sides by 21. That's gone. This I can see, I can divide top and bottom by 7, and that will become 2 over 3 equals x. I'm just bringing the x over. Final answer. Yay! All right, a couple more, and they've got a slight wrinkle on what we've been doing. 31.4. Solve. Okay, these look a little different because we have parentheses, but there's no number in front of them to distribute. There's just a sign. This one's a minus sign and this one's a plus sign. Well, here's the easiest way I can tell you how to deal with these. If there's no number there, you can put one in. Put in a 1. Okay? Put in a 1 so that you can distribute. The numbers won't change, but now you can distribute the sign. If there's a minus sign, we need to distribute that to the other part of the parentheses. So let's do that. It's going to be 12 minus 2x, because minus 1 times 2x is minus 2x, minus 5, minus 1 times 5. Okay? So we distributed the minus sign by thinking of it as a minus 1 and just distributing as we always do. Okay, over here we have minus 2. That's not part of the distribution. That's the little brother tagging along to the story. Now we're distributing the plus 1. And as you can see, if it's a positive 1, it's not going to change anything, right? It's going to stay the same. So it's going to be plus x minus 3. All right? So if there's a minus sign, we have to be very careful because that's going to change the sign of both parts of the parentheses. If we have a positive 1 that we're distributing, we can really just pull the parentheses right off because a positive 1's not going to change anything. Okay? So that's a tricky little thing when you have a parenthesis and a sign but no number. Just fill it in with a 1. Okay, let's add some like terms. 12 minus 5 is 7 minus 2x equals, and then we combine those two, x minus 5. Notice here I've got my plain number and then my x. And here I've got my x and then my plain number. It's fine. It's fine. You don't have to put those any particular way. I'm always drawn to the negative big number x, and I want to add that. Because whenever possible, I'd like to avoid negative numbers. And that helps me. So now that cancels. My x's are over here, so I better add the 5 so that my plain number fish go over there. Make sure I'm crossing out on opposite sides of the equation. I get 12 equals 3x, divide by 3, and we get x equals 4. Yes, good news. Okay, and one more. We're gonna practice this again, and I'll show you how we can shortcut it just a weensy bit. Oh, there's lots of them in this one. I'm gonna go to the other page. I don't like to be, don't fence me in. I don't wanna get trapped at the bottom of the page. That's just very uncool. I don't wanna make you squint. All right, this is 31.5, and it's drama. Are you ready? Oh, that's messy, isn't it? Let me just double check, make sure I copied properly. All right. We're advancing up out of rookie equations, and we're getting into a little bit more of a mess, as you can see from this one, but we're just gonna take what we know and work our way across. So let's start here. We've got a minus sign outside of parentheses, so I'm gonna squeeze a 1 in there and think of it as distributing a minus 1. I know when there's a minus sign, I have to be careful. This makes this minus 4y, and look, this times this, the minus 1 times the minus 17, that goes positive 17. Here, we only have one thing inside the parentheses, but we still have to do the same logic. This is a plus 1. Okay, so when we do a positive 1, it doesn't change anything. So that will stay the same. Equals, okay, these parentheses, there's nothing at all in front of it, so we can assume it's a positive 1, and that won't change anything. So we have 2y minus 1. And then this is like a minus 1 that we'll have to multiply, so that becomes plus y. Whoa, that was kind of a lot, right? If we deduce that there's a positive number or a plus sign outside of this, and we squeeze in our little imaginary 1, it means that we can just pull those parentheses off. They're not changing anything. When we have a minus 1, we have to be careful. If there's nothing written outside, then we can assume we're distributing a plus 1, and that keeps it the same, but be careful of those minuses. Okay. Let's combine like terms. Minus 5y plus 17 equals 3y minus 1. Okay, just for fun, right? My gut call would be to say, let's add 5, so we go that way. Let's just do it the other way. Let's give ourselves a big fat negative number so we can see that it doesn't hurt a bit. So that's gone, and then I'm gonna subtract 17 from both sides. Swimming my fishies. This becomes negative 8y equals negative 18. Divide both sides by negative 8. Right? Remember, when we're trying to get rid of this coefficient that's being multiplied, we want to divide by exactly that same number, so it'll turn into 1. So if it's a negative, we just divide by the negative. It's no big deal. This is where it gets a little more dramatic, is over here. This is gone. We just have y. Now this equals 18 over 8, right? Because the two negative signs cancel. And I can see that I can take 2 out of both of those. So this is going to be what? 9 over 4. equals, and I don't like, this is too squished. I can't write equals y, so I'm gonna write it again. Y equals 9/4, okay? It's very important that somewhere it clearly says this letter equals whatever your value is. And here they got too far apart and I couldn't squeeze it in there. So that time I was forced to write it over again. Please follow that presentation model, right? Save yourself room whenever you can. But if you're absolutely stuck, sorry, write it again. Okay, that's the end of lesson 31. Yay, 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 yay. See you for 32. And I promise 32 is going to be fun, legitimately fun. Thanks, bye.